Okay, welcome back. We're going to work our way through this last example here fairly quickly, just so you can see this last thing that we have to do, and then hopefully you guys have enough to at least get a very good start on the homework that, again, we can polish up when I'm back tomorrow. Um, this last part deals with what's called the complex conjugate theorem. Basically, if I figure out that I have an imaginary solution, I know that one of them will be a plus bi and the other one will be a minus bi. That's basically what it's saying, that all imaginary solutions always come in pairs. So what they'll have you do on these problems is they'll give you 2 or 3 of the roots, and in this case, for example, D that we're going to look at, they're going to tell you that x is -1 and x is 5 minus I. We then have to use that to then find a polynomial that fits that description. So here's what it'll look like. Just a moment. If I know that -1 is one of my roots, then one of my factors will be x minus -1. Always x minus whatever the root is will be a factor. Similarly, x minus 5 minus I, that's another one of my factors, 5 minus I being the root, so I can do x minus that to get my second factor. And then because of that complex conjugate theorem, if 5 minus I is a root, then 5 plus I is a root, and so therefore x minus 5 plus I is another factor. Now, what I'm essentially going to do from here moving forward is I'm going to FOIL my way out to get to the full polynomial. But with these imaginaries, it makes it a good deal more difficult. And so I'm just going to kind of show you how this works real quick. I'm going to move fast, so if you need to pause, raise a hand, get the video paused, and that way you can slow things down and follow along, get this all copied down. So first thing I'll do with the first factor, x minus -1 is just x plus 1. That one's easy, that one's simple, we can do that real quick. The next step is a little trickier. I want to move the parentheses from 5 minus I to x minus 5, and from 5 plus I to x minus 5 again. The reason I do this is because now I have a number, x minus 5 minus I, and that same number, x minus 5 plus I. If you're paying real close attention, you'll notice that in a weird, awkward kind of way, that's a difference of squares, where I have a minus b times a plus b. Okay, a is x minus 5, b is I. Now, we don't see that too often, but here we're going to use that to our benefit to then rewrite that as a squared, x minus 5 squared, minus b squared, I squared. Okay, once we've got it simplified to this, now we can expand this polynomial here using the fact that it's squared, so x minus 5 times x minus 5. We'll rewrite that now as x squared minus 10x plus 25. And if you need to see how I did that, this would probably be a good time to pause, FOIL that out real quick, x minus 5 times x minus 5, and that's how I get up to this point. From here, I can then simplify the I squared. If we remember correctly, I squared comes out to just be -1. So I've got minus -1 at the end of this. That becomes plus 1. And then from there, I'm able to add this 1 to the 26. And then I can use the box method or however I want to. And sorry, that bar is coming up there to block things off. But I'll be able to then distribute it out. So x times x squared, x times -10x, x plus 26, and then do the same thing with the 1. Use the box method, use the rainbows, however you want to do it, but ultimately you should get down to something that looks like this. Now, in a perfect world, I would still have a bracket here and here, but it's missing. I apologize. But that's the idea here. The hard part for this stuff, guys, or at least the new part for this stuff, is everything in these first 4 lines. Okay, that's the new thing. List out the factors, simplify the factors, rewrite the second 2 factors, the 2 imaginary ones, so that they work out as a difference of squares, and then from there you're just expanding polynomials and FOILing out. Okay, that's how you do the last set of problems. Again, I know this is less than ideal since I'm not there to answer questions. Do your very best when I come back tomorrow. Please don't show me any blank worksheets. Show me you guys have tried to do this. If you do it wrong, that's fine. We can fix the errors, but don't don't come back with it blank. All right, use today's time as wisely as you can, and when I get back tomorrow, we'll clear this all up and maybe even be ready to move on. Appreciate you guys' patience working with me. Hopefully my daughter's healthy, and I will see you all tomorrow. Thank you. Go Oilers.